Okay, so today starts our unit on factoring. Now, the whole point of factoring is to be able to find the zeros or the solutions so that we can eventually graph. Okay? The next, really until spring break, everything that we do, all the solving that we do, the whole point is to find the zeros of our equation so that we can graph it. Okay, that's the whole point of solving at this point. So we're going to factor using GCF. Who knows what GCF stands for?
I know it. Greatest common factor.
Greatest common factor. Now we're going to start basic because for whatever reason, when it comes to factoring, this unit, this GCF, is the one thing that students cannot do. Like their brain shuts off and they want to try everything else except GCF, and it's the easiest one to do. Okay, so we're going to have to really focus our minds for this. So greatest common factor. Let's start basic. Let's look at 6 and 18. I want the greatest common factor between 6 and 18. Now, I don't want you to tell me the answer right now. I want you to tell me what that means in your own words. What does it mean when I say I want the greatest common factor between 6 and 18? Tyler.
The biggest number that goes into the lower number.
Close enough. The largest number that goes into 6 and 18. Okay? So I can look at this and I can say 2 goes into 6 and 18. But is that the largest? No. What is the largest number that goes into 6 and 18? 6. So my GCF is 6. What grade did you learn GCF? 5th grade. Okay, so we should be real good at this. Okay. Shh. So for those of you that maybe don't remember, pause. Okay. Shh. So what if you don't remember or don't know how to find the GCF, which is 6? Let's just break this down. Everyone's going to write it whether you knew the answer was 6 or not so that you have something to reference. How do I break down 6? Basically, what's the factor tree of 6? 2 times 3, right? Everyone agree with that? My factor tree of 6 is 2 times 3. I need a factor tree of 18. Now, I'm going to write it on scratch paper so that I can make it pretty on my notes. So if I break down 18, what does that break down to? 6 and 3, and then 2 and 3, right? If I'm doing a factor tree. So all of these here, my prime numbers, are technically factors of 18. Because 2 times 3 is 6, and 6 times 3 is 18. Are you okay with that? I just broke it down. Everyone okay with that? Okay. Now, if I want to find the greatest common factor, I look for what they have in common. They have a 2 in common, and they have a 3 in common. And what's 2 times 3? 6. Did we not learn that in 5th grade? You just had a guess? Okay. You're welcome. Here you go. Okay, so some of you may just be able to guess it because if that's how you learned it, you may know it. But if you struggle or if the numbers get really large and you're like, I don't know, I'm going to be here forever, do a factor tree and look at all the prime numbers. Whatever they have in common is their greatest common factor. He's just mind blown, right? Okay, so before I know you know it, but before we even look at it, I'm going to break it down. 25 is 5 times 5. 30 is 6 times 5, and 6 breaks down to 2 times 3. So it's really 2, 3, and 5. Those are my factors. So that's where the F comes from, the factors of that number. What do they have in common? 5. So that is the greatest number. Just work backwards. Okay. We remember all that? Because now I'm going to throw in some pluses and minuses and variables. All right, here we go. Actually, don't copy that yet. We're gonna break this down even more because I want to be really good at this. Okay, so we're gonna look at 2n to the third, and we're gonna look at 20n squared. We're gonna really break this down before we truly factor. Huh? No, there's nothing there. It's just 2n to the third and 20n squared. I'll put the word and, if that helps. Now, this is not what we're doing. We're just breaking it down for now so that we can really see. Okay. So, not only are we looking for, in this case, the greatest number that goes into 2 and 20, we also have to look at the variable. Okay, so let's start with the number. What is the greatest number that goes into 2 and 20? 2, right? There's nothing else that goes into 2 anyway. So my GCF is 2 so far. Okay. Then I have n to the third and n squared. What is the greatest number of n's that goes into both of those?
N. 2.
Okay, so let's break it down. What does n to the third mean? N times n times n. What does n squared mean? N times n. What do they have in common? 2 different n's, and n times n is n squared. This is like our prelim, like we're gonna build on this. But if we can't identify the greatest common factor, our life is gonna be super difficult as we move on. Mr. Garza knows, he's like, Okay, so we're just gonna keep building. So let's do, I'm writing it as an expression, and that's not what I want. We're going to do this one together before I give you one to try. Okay, so let's start with our coefficient. What is the greatest number that goes into 2 and 14? 2. Everyone okay with that? Okay. Now, how many v's go into both v to the first and v to the first? 1. They both have 1 v, right? So they have that in common. They have a v in common. This first term has m squared. The second term has m. What do they have in common? 1m. Fabulous. This is good so far. This is the first time I've ever done it this way, and it's probably the best decision I've made ever in my life. Okay. Can I throw in something else? I sure can. Well, we're going to. Okay, we'll do it together. So let's think about it. Oh, okay, fine. You do it.
I got it.
So instead of 2 terms, you're looking at 3. So you have to ask yourself what all 3 terms have in common. Not just 2 of them, all 3 of them. So if I look at the coefficients, what does 5, 25, and 250 have in common? 5. Okay, 5 goes into 5, 5 goes into 25, 5 goes into 250. It's the largest number that goes into all 3 of those. Okay? Now, let's look at the b's. Let's look at the b's. So my first term has b squared, and then I have b, and then I have no b's. So how many b's do all 3 have in common?
2, 1.
0. Does this third term have a b? So it can't be there. That just happened because it was a letter. Okay. So, okay, come back. I know you're processing, which is great. Okay, so there's no b's that I can pull out because not all 3 terms have a b. What about k's? I have a k squared, and a k squared. How many k's do all of them have in common?
3.
How many? 2. You can't pull out 3 k's if there's not 3 k's in any of them. Okay, so let's break this down because I think this is where we're getting confused. So b squared, I'm going to write like my first term, my second term, and my third term. So I have 2 b's and 2 k's. I want everyone to write this whether you understand it or not. Okay, so I have 2 b's and 2 k's. That's my first term. My second term has a b and 2 k's. My third term has 2 k's. You have to look at what all 3 have in common. All 3 of them have a k and another k. K times k gives me k squared. Okay, you are looking what all 3 of them have in common. Okay? So try this one. Okay. So if I break apart 16, so I'm going to break apart 16 n squared. So 16 is 4 times 4, and 4 times 4 breaks to 2 and 2, right? So 2 times 2 times 2 times 2 gives me 16. And I have 2 n's. Everyone agree with that?
Yeah.
Okay. 48, 6 and 8. So 48 n breaks down to 6 and 8. Well, I know 8 is 2 times 2 times 2 times 2, and 6 is 2 times 3, and I have that n. I literally broke the whole thing down. What do they have in common? So they have a 2, another 2, another 2, another 2, and an n. So 2 times 2 times 2 times 2 is what? 16. And they have 1 n in common. So my greatest common factor is 16n squared. Okay? Did you say it's extra to show you like that? Okay. So listen, you do not have to do this. I'm not telling you. I don't know why you're talking and not listening. I'm not telling you have to do this. I'm showing you that if you can't figure out what the greatest common factor is, there's a way to do it without like just making stuff up. Okay? Because I know you know how to do a factor tree because we've spent all semester doing a factor tree, and I know you know what n squared means if you break it apart. So if you're struggling finding the greatest common factor, do this. And it may not be for all of them, but some of them it might be. It may not be for the numbers, but it may be for the variables. Don't just guess because you're going to get it wrong. Okay? You have something to show you how to work it out. So, how much time do I have? Here's what's going to happen.
Oh, just as a secret, your grade